All right, the final bit is when we have a binomial distribution, we can actually find the mean and the standard deviation of that distribution. So suppose x is a binomial random variable with parameters n and p. So remember, n is the number of trials. So we got this is the number of trials. This is the probability of success. Of success. Oh, that's messy. I'll clean that up later. Okay, so we've got x is distributed as binomial distribution with n number of trials and probability of success. We can find the mean of this, which is the expected value, is going to be the number of trials times the probability of success. The standard deviation is going to be the square root of the number of trials times the probability times 1 minus p. The variance is obviously the standard deviation just squared, so no square root sign. So let's jump in. So we've got here a fair dice is rolled 12 times, and x is the number of sixes that results. Find the mean and standard deviation of this. So we would say that x is binomially distributed with 12 trials, and then the probability of rolling a 6 is 1 in 6. All right, so now we've got find the mean. So the mean is the number of trials times the probability of success. And so we've got 12 trials times 1 on 6 means we get to 2. We would expect 2 sixes in this space. All right, the standard deviation we've got here is standard deviation is going to be square root number of trials, which is 12, times the probability of success, which is 1 on 6, so that's going to be 2. And then 1 minus 1 on 6 means this is going to equal square root 12 times 1 on 6 is 2. All right, and then we've got 1 on 6 is 5 on 6, which means we're going to be looking at the square root of 10 on 6. Neither of them is a square root, so we would then state this as, so remember, if we were asked for an exact value, this is our exact answer, and then our actual answer is 1.291. All right, just so you've got the definition of this, I'm typing this in my calculator here. So we're looking at, there was 12 trials here. I'm going to type 0, 12 trials, and then the probability is 1 divided by 6. So I'm using the stats mode here. So if I was to get a probability x equals 0, which means no 6, we get a probability of 0.112. I've then got, I'm rushing through these. So just remember the question's finished. I'm just trying to bring it back to a bit more context. So I've gone probability x equals 1, and then I've gone execute, and this next one is 0.269. Okay, then our next one here, we're going to go 2, and I'm just going to do a couple more. So this one is 0.296. So these are the probabilities. I've sort of drawn these upside down. And then the next one here, probability of x equals 3. We're going to see this starts to drop. Okay, so the probability that this equals 3 is 0.197. Okay, now the next one here, we're going to change to 4. And we get probability x equals 4. And that's going to be 0.088. All the way to our final one here would be the probability that with these 12 rolls, we get 12 sixes, and 12 here is going to be, I've got 4.59 to the power times 10 to the negative 10. But what this would be is this would be 1 over 6 to the power of 12 from what we know about this. So you're looking here, what we've got here is this mean of 2. This is our centre in this space. And we're looking at, if you think about your normal distribution, it's not quite perfect for discrete models, but it's saying that we would expect most of the values to be within 1.2 of this. So as you can see, this takes up over 50%. These three data points take up over 50% of the whole distribution. All right, thanks, guys.